Hello students, in video 2 we talk about partial sum and infinite series. Infinite series just simply means that you have a series that goes on indefinitely, okay, infinite number of terms. Well, one may think that, well, if you have a series that has infinite number of terms, doesn't that mean the series just, the sum is going to be infinity, right? Well, as it turns out, sometimes there are other cases where the series actually would give us a finite value, as we'll see in this video. But in order to understand how an infinite series behaves, we have to introduce the notion of a partial sum. So let's define what a partial sum is. Partial sum is denoted by this notation, sum of n. That means the sum of the first n terms of a series. Okay? So let's look at a concrete example. Let's say I have a series, arithmetic series, k go from 1 to n, and the series term is defined by 2 plus k. Okay, very simple one. And when k is equal to 1, I have 3. When k is equal to 2, I have 4. When k is equal to 3, I have 5, so forth. Where does the series end? Well, it ends at k equal to n, right? So that would be 2 plus n. Okay? That would be the last term. And what is the sum? Okay, remember from the arithmetic series sum formula? So that is going to total the first term plus the last term, 2 plus n, right? Added together, multiplied by the number of terms divided by 2. And when you count from 1 to n, how many terms are there? There are n terms divided by 2. Okay? So I may simplify this as simply 5 plus n multiplied by n all over 2. So we can say for this series, the partial sum S sub n is equal to this quantity. Okay. Now let's think about what happens when n keeps increasing. Okay, I'm going to use my red marker here. What if n just keeps going up and up? Okay. Well, that means S sub n is also going to go up and up. That means these values are also going to keep increasing, right? So what we can think about the sum of an infinite series is we can write as n becomes very large, as n approach infinity. What does Sn approach? Okay, what does it become? If you put it in a limit notation, you might write as the following. As n goes to infinity, S of n equal to what? And that would be the sum of an infinite series. So let's examine in this particular case, when n increases to infinity, what happened to S sub n? Well, as S sub n equal to 5 plus n times n divided by 2, if these numbers that I highlighted in red here, as they approach infinity, does Sn converge to any kind of a finite number? No, it just keeps increasing and increasing, right? So this is going to be increasing without bound, or you may say it just approached infinity. So in this case, our intuition was correct. An infinite series that comprise of infinite number of terms, if you just add them together, you just go to infinity. Okay, so in this case, it would be true. And for arithmetic series, in general, if the terms are positive and it keeps increasing, it would just go to infinity. if the terms keep decreasing, and then it would approach negative infinity. Okay, let's take a look at another example. This is a geometric series, okay, and the common factor is 1/2. And the term is defined by 3 times 1/2 to the power of k minus 1. All right, and we're going to define the partial sum just like the way, in the same way that we define it using the arithmetic series. But let's write down the first few terms and see what it looks like. Well, when k is equal to 1, 1 minus 1 is 0. So the 1/2 to the power of 0 is just 1. 1 times 3 is 3. So that's the first term. The second term, I'm just going to write it as 3 times. And I have the factor 1/2 raised to the power of 2 minus 1, which is raised to the power of 1. So it's 1/2 raised to the power of 1. And then the next term, 3 times 1/2 raised to the power of 2 plus 3 times 1/2 raised to the power of 3 plus so forth. What about the last term? The last term is 3 times 1/2 raised to the power of n, right? Because the maximum value of n minus 1, okay? Because the maximum value of k is n, and therefore the last term is 1/2 raised to the power of n minus 1. Now we recall from the previous video that the sum of a geometric series is equal to a sub 1 minus a sub 1 r to the n divided by 1 minus r, right? So let's identify what the different variables are. So a sub 1 clearly is equal to 3. That's the first term. R is the common factor. So R is 1/2 in this case, because each term multiplied the previous one by 1/2. And n, well, n is just n. Okay, so we're going to express it in terms of n. So let's plug those in. What I have then is 3 minus 3 times r, which is 1/2 raised to the power of n divided by 1 minus 1/2. Okay, let's simplify this again. So I have basically 3 times 1 minus, I'm factoring out 3 in the numerator, 1/2 raised to the power of n. I'm going to keep writing it that way. All over 1 minus 1/2 is just 1/2. Okay. Now what happens, and this is now my S of n. So this is my partial sum. Okay. So just like before, when we are examining this series as n increases, meaning I have more and more terms, I keep adding more and more terms into this series. As n approaches infinity, does Sn approach any kind of a meaningful number? Okay. Again, using the limit notation, does the limit n goes to infinity of Sn, does it exist? Well, let's see. So I'm going to switch to my red again. Let's take a look at this term here. 1/2 raised to the power of n. 1/2 is a number that is less than 1. And if you multiply a number less than 1 by itself many, many times, the more times you multiply, the less the value it becomes, right? So when n becomes infinitely large, 1/2 to the power of n basically approaches 0. So what happens to the numerator then is going to be 3 times 1 minus 0, because 1/2 to the power of n becomes 0, all divided by 1/2. And if I simplify this, becomes 3 times 1 divided by 1/2, which is 3 times 2, 3 times 2, and that is equal to 6. So actually, it ends up being a meaningful value, a finite value of 6. Okay, so the key takeaway is the fact that you have an infinite series does not necessarily mean that you don't have a finite sum. The key takeaway is to find the sum of an infinite series, you want to check if the limit of this partial sum as n goes to infinity exists or not. If it does exist, if it converges to a finite number, that means the sum exists. If it does not, whether it increases or it decreases without bound, then that means the sum doesn't exist.